In this video segment, we're going to be talking about equivalent exposure and how f-stops and how shutter speeds and ISO settings all come together to make it the proper exposure for our photographs. So let's take a look at that. What I'm showing you here is how do shutter speeds and f-stops relate. So when we talk about the shutter speed times the f-stop, we get exposure value. And so what we're talking about here is that, for an example, if I have 1/125th of a second as my shutter speed, and then as for my f-stop, let's say I'm going to use f5.6, this is what my light meter has told me to use, 1/125th at f5.6, then to give us our exposure value. Our exposure value is just then, with the amount of light I have available, I would use this combination of 1/125th of a second at f5.6. Now, I might choose to use a different shutter speed for my motion. If, for an example, I want to blur motion, then I could choose a slower shutter speed, such as a fourth or a half of a second. But when I do that, then I also have to change the aperture, because they have to work together so that we always come up with the proper exposure value. So that's what we're going to be talking about in this segment, is how do we realize what is really going on with exposure and exposure value as we change f-stops and shutter speeds. So for an example, let's say that we have 1/125th of a second shutter speed at f8 for the aperture setting. And if we have that, then we can also say that this equals a 60th of a second at f11. Now let's think about what's happening here. If we're moving from 1/125th of a second to a 60th of a second, this means that the shutter speed has been doubled. We have doubled the shutter speed when we've gone from 1/125th of a second to a 60th. When we get to a 60th, the amount of time has been doubled. When we've doubled the amount of time, that means we have to do something with the aperture to compensate. So, if the shutter speed's been doubled, the amount of light passing through the lens must be cut in half for the two exposures to remain equal, thus going from f8 to f11. So what we can say here then is 1/125th of a second at f8 equals a 60th of a second at f11. If I were to take two identical photographs side by side, one using a 25th at f8 and the other taking another photograph at 1/60th at f11, the exposure between the two would be identical. You couldn't see the difference in exposure between those two. You might see a slight variance, though, because of the shutter speed going to a 60th. If there was any motion involved, you might see a little more blurriness in this photograph. Or if I've gone, in this case, from f8 to f11, then what's happening is I'm gaining a little bit more depth of field that we talked about in the previous video segment. So these are the changes that are occurring, but the overall exposure is the same. Now, if I left it at f8, and in other words had it at 1/25th at f8, and then moved my shutter speed to a 60th, which doubles the amount of time that that shutter remains open, and if I were to keep it at f8, I would overexpose the photograph because too much light would be striking the CMOS chip. I would overexpose by what we would call one f-stop. So when you're moving shutter speeds and apertures around, fortunately, your meter takes this into account, the built-in light meter on your camera. But I want you to understand this, because when you're thinking in terms of sharpness of motion as well as depth of field, you want to know what the shutter is doing and the direction that you're moving in. so that you can make your photographs more creative. Let's take a look at this rule. When you double the shutter speed, or making it faster, you must change the aperture by half, or closing down by one stop, thus cutting the amount of light in half, and vice versa. When you change the shutter speed, you must also change the aperture, and vice versa. What I mean by vice versa here is if I change the aperture, then I have to also change the shutter speed, again, to have equal exposure, so that you have the proper exposure, so that you don't over or underexpose your photograph. This is what I was talking about in the previous slide as well. So when you double the shutter speed or make it faster, I have to cut the amount of light in half by closing down the aperture. Now, if I change the aperture, let's just say I'm at f8 and I want to close it down, let's say, to f16, I have to allow that shutter to go much slower to compensate for the amount of light loss by the amount of the aperture that I'm closing down from f8 to f16. This will become a little bit more clear as we progress into some other slides here in just a moment. How does exposure equate to ISO? Let's look at another rule. For every doubling of the ISO number, you also are doubling the exposure and vice versa. So for an example, if I'm at 1/125th of a second at f8 with a film speed of 100, in other words, my camera is set at ISO 100, then I can say this equals a 2/50th of a second at f8 if I'm using a 200 ISO film, or if I set it up to a 400 ISO, I can actually go to a 500th of a second. So keeping in mind how ISO ties together, every time you double your film speed, that allows you to shoot one shutter speed faster with the f-stop that you were using in the previous setting. Notice that all of these are at f8, but what is changing is the shutter speed. The shutter speed here is 1/125th at f8. Here it is 1/250th at f8, and here it is 1/500th at f8. All right, now if I am changing the film speeds, here with 1/125th at f8, I'm using a film speed of 100. If I just go to a 200 ISO, and that's right here, now I can go one shutter speed faster and still leave my aperture at f8. And then if I go to a 400 ISO, I can now go to a 500th of a second at f8. Now keep in mind, the higher the ISO, the little bit, you're going to get a little more grain, or what we call grain in digital photography, we call noise. We're going to have more noise in the photograph with the higher ISO settings. So again, you want to use the highest ISO for the amount of light you're using. In other words, if I'm outside on a bright day, I shouldn't need to probably have my ISO setting at 400. I can probably keep it at 100 because I'm able to do the photography I want with that particular setting. Okay, now let's look at this. This bullet right here. 1/125th at f8 with a 100 ISO equals 1/125th of a second at f11 with a 200 ISO, and 1/125th at f16 with a 400 ISO. I'm doing now just the opposite of what I showed in the previous example. Now I'm leaving the shutter speed constant of 1/125th of a second. I'm leaving that constant and changing my aperture. Now notice I'm closing the lens down each time, f8 to f11 to f16, because as we close down, less light comes through the lens, but if we can increase the film speed to make the CMOS chip more light sensitive, then we can still create equal exposure. So For an example, again, let's take a look at 1/125th at f8. If I'm using 100 ISO, I'm using 100 ISO right here. Now when I go to a 200 ISO film, or increase my ISO from 100 to 200, this now will allow me to close down one stop and still keep my shutter at 1/125th of a second. And then if I increase my ISO to 400 ISO, I can now use f16, still keeping my shutter speed at 1/125th of a second. So let's say for photographic purposes, I don't want to change my shutter speed. I want to keep it at 1/125th of a second. I can always increase my depth of field by closing down to f16 if I can go to a higher ISO setting or a higher film speed setting. And so this is how these are all beginning to tie together so that you can understand what it is how film speeds and shutter speeds and f-stops all tie in together.